So today me and Alex are going to be teaching you about the Taylor and Maclaurin series. So, the formal definition of a Taylor series is an infinite sum giving the value of a function f of x in the neighborhood of a point C in terms of the derivatives of the function evaluated at C. And the definition of a Maclaurin series is the same thing as a Taylor series, but instead C will equal 0, so it would be centered around 0. So what this will basically do, here's a photo I got off Google, is it will best approximate another graph, in this case sine of x, which is the black line, and it is centered around 0 right here. And what it does is as you add more and more terms, what it'll do is it'll approach, it'll get closer. See, this one's only 2 terms, but see 5 terms over here, it's much closer for much longer. So you can use this to approximate values of a graph. And so the actual equation for this, the actual equation would be the Taylor series or Maclaurin series, either one, will equal the summation from n equals 0 to n equals infinity, I mean this would be exact, would be the nth derivative of f of c times x minus c to the nth power all over n factorial. You can use this to create any Taylor and any Maclaurin series your heart desires.
Okay, this is example number 1 of the Taylor and Maclaurin series. The function we have is sine of x, and c equals 0, and it's to the 4th degree. And now we can tell this is a Maclaurin series instead of a Taylor series because c equals 0. In order to find the Maclaurin series, we have to find the 4th derivative of f of x. So f of x equals sine of x, and the first derivative equals cosine x, second derivative is negative sine x, third derivative is negative cosine x, and fourth derivative is sine x. This is simple derivatives. But next, we plug in x equals 0 in order to find the answer, what's necessary to plug into our formula for all Taylor-Maclaurin series that Isaac explained. So f of 0, or sine of 0, is 0, cosine of 0 is 1, negative sine of 0 is 0, negative cosine of 0 is negative 1, and sine of 0 is again 0. Now we use these values and plug it into this formula for all n from 0 to 4, because we're finding to the 4th degree, and that gives us the Maclaurin series. Oh, by the way, this is supposed to say Maclaurin series. But yes, we plug in 0 here, 1 here, 2, 3, and 4 for all 4 derivatives. And you can see that then we can cancel out the 0, the 2, and the 4th degrees because they have zeros contained in them. And then we can simplify that down into the Maclaurin series equals x to the x minus x cubed over 3 factorial. Now this is the final answer for this particular problem, but if we want to take it further, we can see the general formula for sine of x of the Taylor series equals the summation n equals 0 to infinity, negative 1 to the nth power times x to the n plus to the 2n plus 1 all over 2n plus 1 close parentheses factorial. Now, if we want to actually continue this to maybe say the 6th derivative, we just add right here. Boom, 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 boom. And this gives us another one. And there's a pattern actually with the sine of x, and I'll explain that later. Okay, this is example number 2 of the Taylor-Maclaurin series. The function we have is f of x equals e to the negative x centered around negative 4. Now this is a Taylor series because c is around negative 4 and not around 0. And now, in order to find this problem, there wasn't a set degree, so we're just going to find this to the 5th degree because just to make life easier. And this one's actually very generic and easy because it's an exponential function. So when n equals 0, f of x, or just a regular function, is e to the negative x. The first derivative is negative e to the negative x. Second derivative is e to the negative x. Third derivative is negative e to the negative x, and so on and so forth, alternating. And now we plug in x equals negative 4 for all of these derivatives in order to find the necessary values in order to plug into this formula right here for Taylor series. Alright, so f of negative 4 equals e to the 4th. The first derivative of negative 4 equals negative e to the 4th. Second derivative equals e to the 4th. Third derivative equals negative e to the 4th, so on and so forth. Now, we take these values, plug it into these formulas for numbers 0 through 5 if we want to find it to the 5th degree, and we have the Taylor series here. So f of negative 4 times x plus 4 to the 0th power all over 0 factorial, because this is when n equals 0. Now when n equals 1, we have the first derivative of negative 4 times x plus 4 to the power of 1 all over n factorial. Then for n equals 2, we do the same exact thing, plugging in all the information from here, do this formula, you get n equals 2, and we do the same thing for 3, 4, so on and so forth. Now if we want to simplify, we get e to the fourth when n equals 0. When n equals 1, it's negative e to the fourth times x plus 4 all over 1 factorial. And we keep doing this, so on and so forth, for each n, all the way to n equals 5. Then we can simplify it some more in order to get the final solution for the fifth degree of the Taylor series of e to the negative x equals e to the fourth minus e to the fourth times x plus 4 plus e to the fourth times x plus 4 squared all over 2 factorial minus e cubed plus times x plus 4 to the third power all over 3 factorial plus e to the fourth times x plus 4 to the fourth power over 4 factorial minus e to the fourth times x plus 4 to the fifth power all over 5 factorial. Now, if we want to go even further, this is the generic solution for the Taylor series, and we have e to the negative x equals e to the fourth times summation from 0 to infinity of negative 1 to the nth power times x plus 4 to the nth all over n factorial. And now this gives us just the Taylor series for any up to any degree n. And that is the second example. Last but not least, we have the commonly used Maclaurin series that you would most likely see on an AP test or any other test in the near future. So for the functions we have 1 over 1 minus x, e to the x, sine of x, cosine of x, tan inverse of x, and ln of 1 plus x. So 1 over 1 minus x equals the summation of from 0 to infinity of n equals 1 plus x squared plus x cubed plus x to the fourth, etc., etc. This is actually the easiest one. And now e to the x is also a very easy one, and it basically equals x to the n all over n factorial. So it equals 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x fourth over 4 factorial, on and on. Sine of x, this is where it gets where it alternates and skips every single even degree. And so the general formula is negative 1 to the nth power times x to the 2n plus 1 all over 2n plus 1 factorial. So it equals x minus x cubed over 3 factorial plus x fourth over 5 factorial minus x seventh over 7 factorial, etc., etc. Cosine of x is very similar, except it skips all the odd degrees. And so the general formula is negative 1 to the nth power times x to the 2n all over 2n factorial. And we get it equals 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial, so on, so forth. And then tan of inverse of x equals negative 1 to the nth to times x to the 2n plus 1 all over 2 plus n. Now this is almost exactly identical to sine of x, except instead of 3 factorial or 5 factorial or 7 factorial on the denominator, it's just 3, 5, and 7. But it's essentially the same exact thing. And last but not least, ln, the natural log of 1 plus x equals the summation from 1 to infinity of negative 1 n plus 1 times x to the n all over n. And that equals x minus x squared over 2 plus x cubed over 3 minus x fourth over 4 plus x fifth over 5. And now these are really easy because if you have similar functions, you can just substitute in order to get those similar functions. And these are just the commonly used Maclaurin series that you would see on the test. And thank you for learning about the Taylor-Maclaurin series.